chapter 2, we're gonna kind of continue base building just more foundational knowledge on chemistry. So these couple lessons are gonna be kind of short. This, I don't think this is necessary to include in I guess a video series on chemistry, but I wanted to go through the book entirely. So this is lesson 2.1 on the early history of chemistry. It is kind of interesting just to see where the field, how the field grew. It starts with the Greeks. Probably other cultures too, but the book talks about the Greeks and just how they postulated this idea that you hear a lot in like sort of, I guess, pop culture, is like the idea that, oh, there are 4 elements. Fire, I'm gonna draw fire. There's fire, water, I guess earth, like land and earth, you know what I mean? And then there is air, right? So the Greeks thought for the longest time that all matter, all life was just composed of these 4 elements in some way, shape, or form, right? And that's like kind of a reasonable thing to believe. You could kind of categorize everything into one of these 4 categories, right? All of your liquids, there's some sort of composition of water. Any sort of solid is some sort of composition of earth. Any sort of gas is some sort of composition of air. And then fire was sort of that outlier that they saw, and they were like, oh, that must be its own element, because you can't really get fire out of all 3 of these, right? That was their idea. One thing I like about that is just the it models human thinking. Like you have these observations. It doesn't seem very scientific, but really they have these observations, and so they're making an idea based off of it. It's really not scientific, because I guess they didn't really have any good way to get evidence for this, but that's kind of how our brains work. We see things and we want to make sense of them. We see, if you're Greek and you're way before modern technology, you see life around you and you want to make it organizable in a way. It's a very human thing. But there were people in ancient Greece who kind of thought of the idea of atoms, or I guess atomos is maybe how the Greek word is. Some people thought that all matter could just be infinitely divided up, smaller and smaller, infinitesimally, and there's kind of no end. But a lot of other people thought that there was some like finite, particle that built everything. And obviously that idea would win. We have atoms, but that was a thought as early as the times of ancient Greek. Over centuries, this thing called alchemy came through. It's kind of like a pseudoscience. A lot of alchemists really just wanted a way to turn like cheap metals into gold, but alchemy is really, at the time there were alchemists who actually did move chemistry forward. One of the biggest advancements in chemistry, however, going a little bit past that, is Robert Boyle. This Boyle guy was one of the first people who really ran quantitative experiments, specifically on the gas laws. So if you're familiar with PV equals nRT, basically, if you have some gas, it's, N tells you how much gas, R is a constant, T is a temperature. If you have some amount of gas, N moles amount of gas held at a temperature, the pressure and volume are kind of related, like they're inversely related, right? If you hold this side of the equation constant and you increase P, sorry for my brother yelling, then the volume, should, or I guess you can't really, if you were to decrease the volume, you increase the pressure, make something smaller, the pressure will increase. Kind of a intuitive idea, but he was kind of one of the first people to run quantitative experiments in chemistry. It's really important, right? Experiments. Gas, that's how we kind of verify the gas laws. And then he kind of came up with this idea of elements, right? So instead of these 4 very broad elements, he realized, well, maybe an element is just, something is an element unless it's able to be composed of more elements, right? It's sort of like prime factorization, right? 8 is not prime because it can be written as 2 and 4, and then 4 can be written as 2 and 2. But once you hit 2, you kind of can't go anywhere, right? And that's kind of the idea of elements. So if you think about water, we all know that water is composed of oxygens and hydrogens, right? So if this were water, right? If this were water, well, you could do the prime factorization, I guess, and be like, oh, well, this is oxygen, and then this is our hydrogen atom. So hydrogen would be an element, and then oxygen would be another element. You can't go anything past farther than oxygen, right? That's where kind of the bond. Now that's where you have that concrete atom, which is an oxygen atom. So obviously, this idea of elements is going to be really important. Moving on. The last kind of point this chapter talks about is phlogiston. People used to think, I forgot the name of the scientist, but someone kind of thought that this substance was secreted by burning things. And that's actually why if you had like a burning piece of wood and you like sort of put it in a box and you kind of shut it off from the air, the reason it stopped burning over time is because it secretes so much of this phlogiston that the air, phlogiston, I'm not sure how it's actually said, but the air would actually become too saturated with it. Sort of like, I guess if you stink up a room, I guess at a certain point you stop stinking because everything around you is, okay, maybe that's not the best idea, but hopefully you kind of get what they're getting at. And what they didn't realize is that oxygen is just part of the reaction for combustion, right? They didn't realize that at the time. So what they actually called oxygen, they called it like dephlogistonated air, because they just thought, oh, well, oxygen must be so low in phlogiston. That's why it allows things to burn, right? I guess it's sort of like, I don't know, grounding for electrostatics. Like it's just able to take in as much phlogiston as you want. I don't know. That's just what connection my brain made. So it's kind of interesting as humans over history, we've just tried to make sense of the world by these like seemingly plausible ideas. And it makes you wonder, like, how many ideas do we believe in that seem plausible right now that we might one day, we might actually disprove, It's interesting to think about.